Welcome to this UASMaster video tutorial. Today we will talk about the measurement of control points and tie points in UAS measurement. In the last video we finished the extraction of tie points, connecting the photos or images with automatic tie points. We want now to continue the georeferencing part, and therefore we will continue now selecting here on the right side of the UAS tab Measure. First I want to measure control points, therefore I select Measure GCPs, Ground Control Points. When I select Measure Ground Control Points, the multi-aerial view opens automatically. On the left side I will select the Points tab, which gives me here a list of all my control points which we imported during our project preparation. Control points are mandatory if we need to run a camera calibration process, which allows us to improve the camera definition. The quality of the camera definition has a very large impact to our geometric accuracy of the final products, but also it allows us a more smooth processing in general. For this demo data set, we have 18 control points, but 16 of them are only inside the project area. They allow us a very sophisticated and accurate camera calibration. I switch back to Block, and I go back to Properties, and then I activate here my control points. And not everybody will have such amount of control points, but in general, control points should be equally distributed over the complete block, preferable in the corners and the edges of the block. Having, for example, 4 control points in the 4 corners of a squared shaped block would be a nice minimum definition of control points. Of course, a control point should be part of as many images as possible, and preferable connecting 2 strips or more even. We have the luxury in this demo data set to have many more control points. Additionally, also we have for each control point sketches where we can find them very easily in the project. You will find in the input folder a Word document called UASMaster Sketches GCP. When you open the Word document, you will see the name of the control point, the coordinates, and also a location where you can see where the control point can be measured. This is done for each control point which is with our project delivered. So let's start with the control point measurement. We can, in the easiest way to do the measurement, we can double click a control point. We will select the first one called trottoir_1. When we double click this point and we open again our multi-aerial view, we see here multiple images appearing. At the moment, when I make this column a little bit more wider, this control point is predicted to be in 16 different images, which are listed here on top in the multi-aerial view. Currently, we did not measure the control point anywhere, so we don't have any links. If we start to measure the control point and we measure the control point in multiple strips, it will here refer in how many strips the control point can be found. When we use the zoom functions here from the menu bar, then all the windows will be zoomed in and out. At the moment we see the yellow triangle, which is our predicted position of the control point. We can see here the real position of the control point, and they are not perfectly fitting to each other. This pre-position is in relation to different values. For example, our tie point extraction, which is hopefully, well, we will check this later on. But secondly, also from our GPS accuracy. We don't use here high precision GPS, so our GPS is something around 6 to 10 meter accurate. Additionally, also we have height changes in the terrain. So the position of this prediction is somewhere around 6 to 10 meters around the control point, but it can also vary and go further away if our IMU is also not well and the camera is looking to a different position as we assume. I will measure now the first control point here in the first upper left image. Clicking with the left mouse button, I create now a blue cross. The blue cross is my measurement, and now we have a white triangle, which is now a new calculated position for my control point. Having one measurement, I have not many more informations for the for the calculation. So I will add a second measurement. I can see here the control point again, and I click a second time here. With these two new informations, we see now that our prediction changed from 16 to 8 predictions, because with these two new measurements and with the type point extraction, which has a relative orientation, we can now predict better where the point is located, and therefore all of a sudden we have less predictions. This can be easily seen. We see still the 16 predictions from before. If we run now a calculated ray intersection, then this amount of predictions is limited to the new amount of predicted photos. Additionally, also now the calculated position, this white triangle, is newly positioned, and it already fits very well to our position of the control point. The multi-aerial view allows us also to see more than just 4 images. We can here use the page sizer and move it to 9, and then up to 9 photos will be shown directly with its pre-position. The position that is shown here is depending what last calculated function we used. We can either select the calculated, the estimated, or the measured position to be in the center of our photo. At the moment, we made a measurement in the image 3748 and 3779. You can see this either by graphically with the blue cross, or you can see here on the left side in the point image points our two measurements that are listed here. As the calculated position is already fitting very well to the real position, I will use a different zoom, 2:1, and therefore I can see already my calculated position in a better way. Remember, I made my measurement in a different zoom level, so even my measured positions are not correct. I can either manually now make a correction by just clicking again here, positioning the blue cross somewhere else, or also what we can run is a semi-matching algorithm. You need to have at least 2 manual measurements done. You go into one of the windows that you already have measured, you right-click the mouse, and you can now select Complement and Refine. It will try now to use this position and measure it automatically at the calculated positions everywhere else. We see the automation was successful for 3780 and 3749, but it failed for the 2 images with the vegetation and also for the 2 images where we see the blurring effects causing different pixel shadings than in the original one. We can either keep the automatic ones here and just measure manually the remaining ones by just clicking in them here. And if we are not sure, we leave the measurements out here and don't use them. In the point image points, we see the mode, how the point was created. MAN means manually measured. LSM means it used the least square matching, this automatic function, to position the point. Let's assume you made by mistake a measurement and you see this is wrong now. Then you can also delete this measurement. Either you right click into this image and you select remove image coordinate, which will remove this one single measurement, or in case you select clear image coordinates, it will remove all measurements from the complete control point, so all 8 measurements that are here remaining. You can also go here into the list and select from image 3813 the measurement, and you can select here to remove this one measurement. Or if you take this measurement here, which you are not perfectly sure if this is correct or not, you can keep the measurement and say, well, for the adjustment, I will just deactivate this measurement from 3781 and check off this box here. And later on you can introduce it or remove it again as you wish. So looking at the points tab, we can now see 8 predictions, 7 measurements, and we have these measurements in 3 different strips. We can easily continue by double-clicking the next control point. I will do this here with 2021, and then again the preposition is shown here. We can zoom out again, look where the control point is located. We can see it here in this image here in the most left part. I can measure it in this low resolution. Then I can again here, I see it's not anymore in my left image. So I can position it to the calculated position, zoom in, and then make here a better position of this point. And we see now this is only in one photo existing. I measured, it's predicted in one image, I measured it in one image, it's in one strip. So now the prediction is green. Green means all predicted positions have been measured. Yellow means you have more predictions than measurements. Red means the photo or this control point exists in the project, but I did not measure it. And blue means this control point is outside the project area. The point list offers filters, which allow us to focus only on specific points. If I don't use a filter, then we see additionally all the tie points that are already existing here in our project. As this video tutorial is mainly based on the control points, I used here the GCP and check only, so ground control point and checkpoint filter, which displays only my control points and checkpoints. The tie points that we have use an automatic naming, which makes it easily to understand they are not made by a manual measurement. If we want to add a manual tie point, it's very easy. We can use here a naming function. I will call my control points, my manual tie points, MAN underscore tie point underscore 001. And if I click now in the block view somewhere with the measurement function, then I add now this tie point. If I go to the multi-aerial, it gives me a prediction where the position of the point is predicted, as I mentioned. I zoom out again. It works very similar in this case to the control point measurement. I add now 2 positions. In my case, I make it very easy. I use this control point here, which can be seen in 2 different images very easily. Then I run the calculated ray intersection, which reduces the amount of images where to find this point. And it already gives me the pre-position. I can now here zoom in and measure the tie point on my own location that I want. I will use here these 3 dots. So I use here these 3 dots and I use here these 3 dots. And now again I can right click and I can say now I want to either refine. Refine means it will only refine these 2 measurements. It will not complement the other remaining photos. Complement will keep my 2 measurements and only the other photos that are not having measurements will be added. Complement and refine will now add all possible other measurements and also try to refine them with this least square measurement. So we can here again move to the calculated position, zoom in, and either finish the other measurements manually by selecting here this stone here that exists. Also add our manual ones because they were not placed correctly here. If we are not sure where the position is, we leave the measurement off. We can use the green arrow to move to the next images. If we don't see exactly where they are located here, we leave them open. We see how blurred photos can be and how difficult they can be measured. And that's the same also problem for the automation tool. It will also have problems to automatically fill these points or find them. We can easily then increase by clicking here on the left button, and it will automatically move to the next number, and then we can again go either in the block view, click to a new position, here again go to the aerial view, measure manually the tie point, increase our tie points for the block, which will then be used later on in our process for the orientation of the block. Manual tie points are used for stabilizing the block. So that means if we have missing connections between images or strips, we need manually to add tie points to stabilize our block. For this demo data, we would now go and measure all our control points and checkpoints. Double-clicking the control point, zooming out, searching where the location of the control point is. If we can detect this point in two different photos, we will then measure the control point here. I will here use only 4 pages. Zoom out. If we are not sure where the point is located, we can also use here on the bottom right of each photo this button to maximize the photo positions. Then if we are not sure if this is the signalized control point, we open up for control point 2015 here our sketches, and if we look at 2015, then we see the control point is here located on this open field here, so we can then go minimize again this one here, zoom further out, check where this location could be. If we are not sure if it's in this one, we go to the next one or the next 4 photos until we detect the position. In our case here, this is the location of our control point. So here's one of them. Then we can go to the next photo. Here we can see it again. We measure it here. After we measure 2 of them, we can now use the calculated ray intersection, and we see now it's only in 3 photos existing. So we measured it in these 2. This is my 3rd one. Then I can use here now the refinement because I don't need to complement, and it will use these 3 measurements and try to use this selection here to make a correction for this one, and we see it was successful for all 3 of them, which gives us now a good sub-pixel position of this control point. We would now continue and do the whole process for all the other control points and checkpoints, and then we are done with the measurement of our control points for our demo data. As mentioned at the beginning, you could also try to simulate a minimum configuration, which means you could just measure a control point in the lower right corner, which is already our trottoir, one in the lower left, which would then be control point 2013, one in the upper right, which would then be, for example, 2001. And as we don't have a control point in the upper left because 2021 is only measured in one image and it does not give us a lot of stability, I would then use the control point 2011 if you only want to run with the minimum configuration. But to achieve the highest accuracy for camera calibration, I recommend strongly please measure all control points. I will shortly do it and show you then finally how many predictions and links we will have approximately at the end. Here the summary of all the measured control points. We were able to measure the following control points with the following predictions and the following amount of links. I hope this helps you now that you can get measured all the control points for your project. and in a following video tutorial we will show how to continue with the orientation and camera calibration. Thank you very much for watching this video tutorial.